good morning from Rye. This is Danny Cherrod here from Rye, New York, and I will again buy some time here. I'm here with Ofer Shalev, a very interesting entrepreneur.
Hi.
About it from Israel. Hi, Ofer.
Hi, hello.
And Ofer is in Petah Tikva, which is a neighboring city to our offices, by the way, in Israel. So before I will start a conversation, I will just update you a little bit here. First of all, we've been dealing with, we will be talking about something very interesting today, which is basically if Ofer and New Phase are going to succeed in what they are saying they're doing, which soon we will talk about it, managing to kill, destroy bad infected cancer cells while keeping the good cells alive. It's obviously a huge breakthrough. We've been dealing with cancer a lot lately. Those of you that's been with me last week, we had two of the most important surgeons in breast cancer, another company, and we talked about what they do. And next week, also around healthcare, not really cancer, more like COVID. So just so you know that next week we'll be having on, which day is it next week? We'll be talking to Mount Sinai with Dr. David Petrino, and that's on October 27th, which is actually exactly 1 week from now, next Tuesday. So that's going to be an exciting session as well, talking about how COVID affects the hospitals and everything. As you may know, at the end of this month, October 27th, I believe, we are doing our online conferences. We have one for the US, one for the Canadian market, each in 2 parts of 2 hours, and amazing speakers. In the US, John Katsimatidis, the heads we have an AI panel with the heads of AI at Levi Strauss, H&M, World Economic Forum, Boston Scientific Group, Microsoft, and many others. And in the Canadian conference, we have families like Steve Apostolopoulos, Saputo, Patricia, both brothers of the Gaspé, 14th generation, I believe, Philippe and Francois, and many, many others that are very exciting people that we're going to be having here. And that's going to happen again starting October 27th. It's basically 4 different parts because each conference is held in 2 shorter parts, as I've mentioned. Also, Sylvan Adams, which many in Israel know, will be speaking at the Canadian conference. He's a big philanthropist, an investor, and a great guy. So that's really in a nutshell. So now I'm ready to speak with Ofer. And what's interesting about Ofer, like many of my guests, Uri Levin that founded Waze and others, sometimes their bio is very short. They don't like, big, arrogant, long bios. Ofer, I've known for several years. We met before, and this is not his first tech company he's leading. He has 25 years of senior managerial positions in the medical devices world. So I believe as an entrepreneur, he had another company that he founded. But even before that, he worked for many years as CEO or senior positions in healthcare companies in Israel and high-tech sectors, both in Israel and abroad. So Ofer, good morning.
Hi, good morning.
So let's start. I mean, basically, when I looked at your information that you sent me, I was like reading it. There was the technical issue that I didn't really get, but then I saw the bottom line and I basically reached out to you and said, this is crazy. If you guys manage to do what you claim you can do or possibly can do, this is a huge breakthrough. So maybe we'll start with an explanation about what the company does. We'll talk about your life and how you ended up doing this shortly, but let's start with maybe a description of what you guys are doing.
Okay, so before starting discussing the technology, I would like just to quote to your to the headline, how to destroy cancer cells without affecting surrounding health system. So this dilemma we faced in the early days of our research, and the question was how to define between the bad guys and the good guys. So this kind of dilemma, I mean, I believe that many policemen have in a criminal incident, how to neutralize the bad guys without hurt the good guys, or in all the other events of the special forces while dealing with a hostage event, and again, how to take down the criminal, the bad guys, without hurting the innocent people. So usually those situations, the same as our situation, is crowd population, while bad guys and good guys are mixed together. And the same like in our, while dealing with cancer, so the cancer cells and the healthy cells, they are crowded together. I mean, they are one nearby each other. And you don't want to hurt the healthy cells, only the cancer cells. So we want to define between those two groups and how to destroy only the cancer cells and not the healthy cells. So we learn deeply what the character, and mainly the physical character or parameters, and we understood the following. So cancer cells have much more receptors or pores on the membrane, and therefore they are much more fragile to physical force or physical damage like heat or hypothermia. In addition, the cancer cells, they have a very poor lymphatic drain or poor blood drain, meaning it is a poor perfusion, or in other words, the very low cooling of the cancer cells. So the outcome was that cancer cells cannot tolerate temperature of above 45 Celsius, which is quite high. On the other hand, normal cell can survive for a longer time in this environment and up to 47 and 50 Celsius. Meaning in the cancer cells, we found that there is a fragile membrane and a poor cooling system. So once we understood that we have here a way how to define those two groups, we look for the right ammunition. And we have decided to build a hyperthermic control environment of about 47 to 50 Celsius. And this environment, the membrane of the cancer cells will be destroyed or collapsed, while there will be no damage in the integrity of the health system. I mean, this is the idea behind our technology, and later on we'll discuss probably about technology, how we implement this vision.
And then we'll talk about how you actually manage to heat the cells and all of that, and the machine you built around it, which is fascinating, by the way, because I already looked at it before. So maybe before we dive into your technology, which is the most interesting part, I would ask you your, maybe just like as a background for your story. How did you end up doing this? I think you shared with me how this company actually started, which
Yes.
is a very touching story and an interesting story. And some of the most amazing companies that I've met doing what I do, and you meet a lot of companies. Some of the most exciting stories start because of someone's either personal interest or passion or life, that brought him to care about something. So if you can share with us that would be great as well.
Okay, so the story of New Phase actually started about 12 years ago, while the mother of my partner, his name is Dr. Rafi. He is a doctor for mechanical engineer. His mother, her name was Sarah. She had a lung cancer. And at that time, Rafi thought about how to find a way to buy her life, meaning to be able to change her disease, lung cancer disease, into some kind of chronic and buy life again and again and again by ongoing treatment without causing all the side effects that we're all familiar, and to allow her to live a normal life. Unfortunately, she died 10 years ago. And about 1 year later, we started with this initiative of New Phase. And as usual, in the first 2 years, we work in the garage. until we reached to find a proof of concept. And that was about 7 years ago. At that time, we have done the first round. And in the last 7 years, we have a dramatic improvement in reaching to a status while we are almost ready, or we are ready to start with a human study. A lot of R&D, many areas that I believe that nobody stepped there before in the nanoparticle and in the RF technology that we are using in order to activate our nanoparticle. But yes, here, I mean, this is the story, but currently, yes, we are here.
Now, let's talk about the actual technology. I mean, people's first question would be, how do they manage to do that?
Okay. So let me.
So that's the most exciting part, I think. Let's get down to it.
Let me share screen. It's okay?
Perfect.
Okay. So as you can see, the name Sarah Nanoparticle technology is on the name of my partner, Rafi. Her name was Sarah. And the idea and the look for the bottom line. I mean, we are looking about medicine, engineering, and physics. The basic idea here about physics and engineering, sure that we are employing chemistry and biology, etc. But the main idea is about engineering and physics. So the Sarah nanoparticles, as you can see on the sketch on the left side, there is about 8 to 12 very small iron oxide in this nanocapsule. And there are around there a phase change material. Phase change material is a kind of a buffer. It's based on physical phenomena calling latent heat. And this kind of material can stabilize the temperature to predefined temperature. Meaning, if the iron oxide, for example, will be under RF radiation, they probably will start to rise temperature to very high temperature, to ablation temperature. And we don't want that those kind of nanoparticles will be around our body and cause any damage. And therefore, we have developed a way, and sure that we are patented it, that with this phase change material, we can control the temperature to the range of 47 to 50 Celsius. That's all. I mean, the temperature cannot rise more than that. And that's what I just described at the beginning, that at that temperature of 47 to 50, the cancer cells are just dying, while the normal cell can exist. And in the surround area, there is a PEG, a kind of outer layer. On the right-hand side, you can see a picture in the electron microscope, and you can see the size of it, which is 135 nanometers. Now, with regarding to this side, let's go to the other side. In the other slide, at the bottom, you can see the well-known coronavirus, COVID-19, and his dimension is actually the same, is 125 nanometer. Now, just imagine that in this so small kind of a virus, we can put about 8 to 12 nanoparticles in a kind of phase change material and cover it and inject to the body billion and billion of those identical nanoparticles. That's what we are doing. We have developed our ability in the clean room to manufacture human dose or pig dose in order to be able to support our further clinical study. So again, in each dose, there are billions of those nanoparticles in the side of the COVID-19, and they are fully identical one to each other. Just on a glance to explain what does it mean latent heat. So here you can see in the graph, in the up curve, it's a free iron oxide under RF for a period of 1800 seconds, which is 30 minutes. And it's reached to about 75 or 80 Celsius, which is absolutely ablation temperature. On the other hand, the same nanoparticles, the same iron oxide, while encapsulated in our technology, you can see below that they are reaching only to the range of 50 and a little beyond. So that's what we mean by saying latent heat phenomena. The gap between those two graphs is actually our ability to control the nanoparticle and to keep them in a predefined temperature. Last item of our technology is a radiation machine, because we want to activate or stimulate the nanoparticle in order that they will reach the temperature of 50 Celsius. And it looks like MRI. And actually, it's like microwave in our home. And if we put in our microwave a spoon, for example, they will reach immediately to some hundreds of Celsius. And that's what we are avoiding. We can keep the temperature in the predefined temperature that I just quoted before. So here you can see the first RF machine almost ready in a final test, and will be shipped probably very soon to Israel for the human study. So this is just on a glance about our technology.
And what do you stand regarding the phases? I mean, what's where are you now? What's the next stage as far as developing?
Okay, so let's try to move back into the okay. Okay, so here are the achievements and the milestones of the company. So let's start with from the left side. The first 7 years, we have made all the R&D and run many, dozens of safety and efficacy and hemocompatibility, all what is required for the preclinical studies in animals, both mice and pigs. And we have manufactured the clean room for ongoing preclinical study, meaning the current clean room can support all the preclinical study that we have done, and can support all the next phase of a human study, which we will conduct in Israel and North America. And we have designed and built the RF machine. And by the way, the current machine are assembled out of our labs, but we have built by ourselves. We have designed and built by ourselves the first machine for mice, and then for pigs. And by that, we gain a lot of knowledge and know-how how to build this machine, because again, it's like the nanoparticles. It was an area that you cannot buy it in any place. You have to design, develop, and manufacture by ourselves. And yes, we have done it. We raised until now, in the last 7 years, $23 million, and we have 6 patents, 2 of them in oncology, which already granted in the main territory, meaning US and Europe. In the coming year, 2021, we plan to start with human trial. So currently we have approval from the Israeli Ministry of Health to start the human study. And we had several meetings with the FDA, and we agreed with them about the IDE submission, which hopefully will be in Q1. We actually at the beginning we planned to make it before, but due to the current situation with Corona, etc., we switched between Israel and the USA, and therefore we will start probably in the middle of the coming years with North America, and the same with Canada. The first phase, called early feasibility or phase 1, there will be about 15 to 25 patients. And then let's move to 2022. Based on the result of phase 1, we will start with phase 2, we plan based on this on the result of phase one. Let's start with a third point to probably to raise probably through IPO about $40 million in order to support the phase two. Phase two will be probably in 4 or 5 American hospitals, about 250 to 300 patients. And as I mentioned, that will probably start in 2022 for a duration of about 2 years. And after that, in 2024, we hope to be able to make the submission of the PMA to the FDA, get the approval for this technology, and start the commercial activity, probably with oncology player, in order to launch this technology. So this is actually the current and the further plan for NuFACE for the coming years.
Now, can you share with us? You can feel free, unless you have more presentation to show, to jump back to our to close the share screen, unless you want to show us anything else here. I guess my next question would be, what else is out there? I mean, when you're looking at what you guys do, what is the closest thing there is to solve this problem? What's your competition really?
Okay, so there are several companies, they're all a startup, that are in the business of hyperthermia in different approach. There are, but what is common to all of them, since they cannot control the hyperthermia, all of them have launched or developed a local treatment. By local treatment, I mean once the oncology can identify it's not metastasis, it's about a tumor by PET-CT or MRI, then they inject the material into the tumor and make a local treatment for it. And there is about MagForce and Aeroshell and nano X-ray and MIND and et cetera, et cetera. But in common, all of them have developed a hyperthermia technology for local treatment. We are dealing about spread metastasis. So our treatment will be systemic treatment because we are not worried from our nanoparticle to be heated more than what we plan for. And therefore we can use it for systemic treatment. And this is a huge difference. I mean, the technology of hyperthermia is well known, but currently, because nobody else knows how to control the temperature, only we develop this technology to treat with systemic metastasis.
We have a couple of questions before we'll continue with the questions I have for you from the audience.
Okay.
So let's see. From Dr. Nicholas Beercroft in England. Good morning, good afternoon, actually, good noon. How do you make sure the nanoparticles don't concentrate in other organs, such as the liver, kidneys, and cause harm there? Why not use gold, silver, platinum nanoparticles with pulsed electromagnetic fields?
Okay, so yes, we are concentrate in the other organ as well, but we don't cause them any damage, and that's why what I started at the beginning. Yeah, we are concentrating in the other organ, in the other tissue as well, but without causing them any damage, and we proved it in dozens of the studies. I mean, that's it. And the other question was about other material, other metal. Okay, so we have started at the beginning, for example, with gold, but we found out that the frequency in order to activate gold, it's in megahertz, and that kind of frequency cannot penetrate a volume of a body. It's very good for mice. Yeah, we have done it in mice at the beginning. And once we move into other animal, we understood that using the megahertz will not be useful. And therefore we changed from gold in this example to iron oxide.
Can we possibly use it to target corona? Maybe to change the thermal threshold needed for the virus ablation?
Well, we actually I thought about it, but let's focus about the cancer. But yeah, I do believe that while we will be able to, mainly in the lung, to heat the lung under control, not to ablation. We are not reaching to ablation. We are reaching to a sub-ablation temperature. So probably or potentially it can help, but let's start with what we have started with, which is oncology.
Is there a need to deliver the nanoparticles close to the cancer cells? How
No.
much of the cancer cells can be destroyed this way? Is the objective to reduce the tumors significantly enough to allow the body to defend itself against the cancer cells that remain? And what impact does the temperature increase have on apostasis of field in general? That's like 4 questions right there.
It's a long question, so yeah, let's start. Okay, so we are injecting the nanoparticle IV into the vein, okay? And then the nanoparticle just go in the body, and using a mechanism, if there are biology or doctors, they're probably familiar with it. It's a EPR effect, enhanced permeability and retention, which mainly describes the leakage phenomena in the neighborhood of the cancer tissue. So that's how we reach to the cancer tissue. It's well-known mechanism, and we prove that it works very efficiently. And by running many of efficacy study, we learn, not in human yet, we learn that we're reducing the mass of metastases by about 40 to 50%. And we are doing it in all the group of mice, meaning it's not that one mice are being affected and the other one no. All the groups of treated mice, all of them affected by this technology, and the number of metastases just reduced dramatically. What was the other part of the questions?
Oh, it was serious. Is there a need to deliver the nanoparticles close to the cancer cells? How much of the cancer cells can be destroyed this way?
40, 50%, yeah.
Is the objective to reduce the tumor significantly enough to allow the body to defend itself against the cancer cells that remain?
Right.
What impact does the temperature increase have on apostasis of field in general?
Well, we never find in all the studies we have done in mice and on even a big animal like pig, any evidence to any hyperthermic damage in the organs. No, we didn't.
Thank you. So we'll probably have more questions coming up, and let's continue our discussion here. And I think, you know, one of the most interesting things about us, I think one of the most fortunate things about us, Ofer, that I learned to be an interesting advantage was the fact we are the only group in the family office space that comes out of Israel, which means we're meeting amazing entrepreneurs like yourself. So we find it a big plus. I have a good friend of mine right now from Dubai, from Abu Dhabi, that just joined us. So good afternoon to you as well, my friend. As you may know, the new peace agreement puts us in a very interesting place, and I will also share that with you later on, Ofer. We have very interesting plans to bring technology there, and we're working on exciting ventures. So just a small remark about that.
Danny, let me respond to you. If you can take his email, I will be next week in Dubai.
I will connect you. He's a good friend of mine. We've been overwhelmed with how great you know, people are, how kind and how interested they are in doing interesting things with us. Good morning, Ahmed. So I want to ask, you know, I always touch the COVID issue, right? I mean, it affects us. And before I'll talk about what kind of money, what kind of capital raise you're looking at, how does COVID affect you, your life, and your company? I mean, a lot of companies got stuck in the middle of a raise. It made things difficult, and others actually it helped. So how do you guys deal with COVID? How does that affect you? How is Israel doing? You know, I haven't been, I'm in New York now. Is the siege off? Is it still on? What's going on?
So amazing enough, in March, I declared in the front of my team It is not going to be a crisis, it will be opportunity. And that's what we have done. We have, we have many labs that we work in USA and Europe that just shut down for the corona. And we succeed to manage and transfer many of the studies to some other countries. And we have just remarkable things during the last 6 months. I would say it didn't affect our work. Probably it even pushed it ahead. And I would say something else. We have started fundraising about March, April for $10 million in order to support the first-in-one study, which will, as I mentioned, start in a very short period of time. And amazing enough, during the last 4 months, we raised also already $3 million from investors that was impressed by our achievement in the field of the oncology. And furthermore, they will be highly impressed by all the steps that we have took in the COVID-19 and we turn it from crisis to opportunity. So this how we see the COVID-19.
That's the biggest challenge, I like, that's when we started to do our online sessions, we talked about adapting and, managing, and obviously not everybody can adapt, but most probably can. And, some of the biggest and most interesting businesses in the world started in crisis.
Right.
2 of the families I actually interviewed, Saputo, that's one of the largest dairy companies in the world, and Sheraton. Both started in the Great Depression. You touched that a little bit because I asked you, but maybe again, where are you today? And what's planned for the next years? How many years before you see an end product? What's the global plan and what you've established so far? How much, and by the way, maybe also how much would be the minimum check you would be looking at here?
Okay, I mentioned before that since the company was established, we already, in the last 7 years, we raised $23 million. All of them from private was investor and from a family office. All the shares in the company, they're all ordinary shares. No preferred share, no anti-dilution, nothing. And I believe that probably that was maybe one of the reasons that the VC don't like to invest in new phase, but it's fine because other investors, as I mentioned, private and family office, decided to invest in new phase, and that will be even the current round. I believe so. Although we will welcome if a VC will take a decision and agree to invest in while getting an ordinary share and not so other kind of shares. So the minimum is $500,000 in this stage of the company, and just some data about the world of a cancer, and more specific about lung cancer, because we will start with lung cancer, and more specific at the beginning we'll start with a small cell lung cancer, which is a highly aggressive type of cancer. In the last 30 years, there was no any solution, any technology to treat it, and we have decided to use it to choose this because we are a small company and we want to show what great technology we have done. So taking care about maybe an orphan disease that we will make some breakthrough will push the company very strongly ahead. I just want to say about this decision about the small cell lung cancer, this technology is target all the solid tumors, meaning all kind of breast cancer, lung cancer, and colon, and pancreas, etc., all are declared as solid tumors. It's actually about 85% of the market that we have solid tumors, and then all the other, the blood, the leukemia, etc. So we are focused about solid tumors. Just to give some figures, the lung cancer market will reach during the 2020 and something to about 13 billion US dollar. The current oncology market as of now is 140 billion US dollar in terms of drugs and medical device. So it's a huge market, and whether we say unfortunately, but that life, it's not going to shrink. It's just going to grow more and more. So, I mean, the market is just huge.
And can you tell us a little bit about the team? Who is involved? I mean, you mentioned briefly, but let's talk about who's there, how many, where.
Okay, so let me just switch back to the...
And we're getting some more questions, but I'll address them after that.
Okay. Okay, so there is myself and Dr. Afichov. In the advisory board, we have two oncology, Dr. Gus from the Ottawa hospital and Dr. Sichon from Israel. We have also Professor Dan Pierre, which he got his professors in Harvard, and currently he chairs the director of precision and nanomedicine in Tel Aviv University. So we have in the board of directors, in the advisory board, both oncologists and academic. And with regard to our team, we are 24 employees, 17 of whom have a researcher. We have 6 PhD in chemistry, biology, physics, and all the other have master's degrees. So we are highly educated or highly talented in our company. And just to explain, while dealing with nanoparticle, it's really a multidisciplinary area. And therefore, we have research in biology and chemistry, engineering and physics and electronics and sure QA and regulation. It's very spread of researchers that we have in our company. And 2 more points. Out of this 24 employees, half of them women. And furthermore, in my management, we are 6 people in the management, and again, half of them are women. And furthermore, we have, I mean, the one who are familiar with Israel, we have in Israel Druze Muslims, and we really feel with them like a brother. I mean, they call Druze. They belong to the Muslim. And we have decided to open in the Galil a lab with 3 Druze women, which are chemists, and we are developing and build them some subsystem of our nanoparticles. So yeah, we are a highly diverse company, and I believe it's a great advantage to us while having different sector of researchers, women, men, etc. So yeah, it's part of our success. I do believe so.
I would like to also tell you that I like to say when I'm asked to speak, and I did speak at a conference just 2 days ago in Latin America, that I feel that family offices care about things like that. It's not only that you're doing something good for society, and I believe that you see the value in your employees, whether they're Muslim, Jews, Jewish, women, men, because of their capabilities. I'm sure you don't see yourself as doing any philanthropy here, but you are doing something very right that I think families appreciate. And we once built a panel at one of our conferences with a company you may have heard of, Pruiston Pharmaceutical, and they brought an investor that ended up investing in them because of a social issue they were, in how they hire people that they fell in love with. So I think this is something families really care about. The impact, doing good for societies, things that maybe VCs and institutional investors would care less for because they don't see where the money is here. But I think it's a great value. So it's not only about, It's great. It's great. I think, especially with what we're planning to do in the Emirates, we should talk about these things here.
Right.
So I have some more questions for you here, but before that, maybe a couple of more questions from our audience here.
Yes.
So what happens to the accumulated unused particles? Won't they be toxic on a longer time?
Okay. No, they are not toxic, and we have learned it from studies of that the residual material was in the body for 1 month, 3 months, and even 6 months. But furthermore, we have developed a very sophisticated system in order to evaluate the excretion rate from the body. And we know that about almost 50% of the nanomaterial, the Sarah nanoparticles, excreted from the body after 1 week, and it's keep excreted a long time. I believe after 90 days, about 65 or 70% leave the body. So those nanoparticles leave the body, and furthermore, since we have discussed the issue of repeated treatment, so one can ask what happened to nanoparticles that are being irradiated again and again and again, which is right, and nothing happened. And that we learned from many toxic and safety, and including a histopathology evaluation on the organ, and there was no any sign to any inflammation caused by the iron oxide or by hyperthermia, whatever.
Is the number of nanoparticles per molecule constant? Does the temperature change depending on the number of nanoparticles?
Yes, and one of the, I discussed before, the ability of our clean room. So yes, it's between 8 to 12. In 8 to 12, nothing happened. But if we will put, for example, 25, sure, it will change the heat rate of the nanoparticle. But that's one of the knowledge that we develop, and we are in a very tight way, control the nanoparticle. We are using a lot of leading technology in order to evaluate what we are manufacturing, and we are very consistent way doing the same and the same and the same.
Okay, that's a long one. Can your device be used to target areas which have been previously radiated with conventional radiation after cancer surgery? And the second question, okay, you want to answer that first? Okay.
Yeah, right. I mean, you mean, probably he mean about ionizing radiation. So the answer is yes, but again, our radiation, I mean, we are not ionizing radiation, just you have to remember it. But yes, we can irradiate area which before that were ionized by some other radiation.
Can it be used if there is no evidence of specific metastatic disease in the patient, but there is evidence of cancer cells by reason of a rising PSA reading after a radical prostatectomy? And I read everything perfectly until now, and they had to put that one last. No, I'm kidding. Yeah. So that's really the second question. Can it be used if there is no evidence of specific metastatic disease in the patient, but there is evidence of cancer cells by reasons of rising PSA reading?
Okay.
Yeah.
Okay. So assuming the cancer cells are larger than 200 micron, meaning 0.2 millimeter, yeah, we can use it. Because I mean, those metastatic will not be able to be identified by CT, MRI, but while reaching to 0.2 millimeter or 200 micron, the phenomena of the EPR will start, and once it will start, we'll be able to reach them. I hope I answered the question.
Is there a risk of overdoses? What could be the side effects? Is there no chance to get healthy cells damaged?
Well, we have one part of the test that we have done was in order to mimic repeated dose. And since we know how to calculate the residual volume after each treatment, So we mimic 3 treatments one by one, and we reach to 150% of dose, and it was totally safe. So, I mean, this technology from the beginning was designed for repeated treatment, meaning the ability to pass the 100 dose.
Ooh, more questions. Is a patient with small cell lung cancer a potential eligible participant in the next phase?
Yes, we are going to start with a small cell lung cancer, assuming that he has a sufficient lifespan of about 2 or 3 months, because usually those patients have a very short span of time.
Have you been able to analyze the cancer cells after the heat treatment? Were they destroyed as expected? What is the process of destruction? Are the outer cell membranes destroyed? Membranes destroyed?
Yes, we analyze it by several methods, and we know that the majority actually was destroyed by heat destruction, and some of them, about 24 hours later, died by apoptosis as well.
Got it. Okay, I think we covered most of the questions that I had here. Please, any more information that you can give us about what's coming next.
Yes. So
and how much, did we talk about how much was initially raised, how many years the company is being around? Yeah.
So as I mentioned, we are 7 years around without the 2 years in the garage. We raised $23 million US dollar till now. We are looking now for $10 million US dollar. Within, as I mentioned, the next year, at the beginning of 2022, we hope, based on the results of the phase 1, to start with IPO and to raise about $40 million US dollar. And while saying IPO to a private angel and to a family office, I believe it's a good news, because at that time the investment have a liquidation, and it's not so many years until we will reach to this point. And I would say let's just go to some slide before. Sorry for that. Here. So you can see that in this area of cancer there are many unicorns. Okay. And I believe that probably all the oncology companies pass the $1 billion US dollar at either acquisition or IPO. So I just hope that that will happen with our company as well, besides of doing good in the world. So yeah, that's it.
Okay, if you could just unshare your screen, so
okay, yes.
See here if we have any more questions coming. Thank you. So I don't see any more questions coming at this point. And maybe I'll ask the families that so far invested with you. Are they global? Are they mostly from Israel? Who are your investors?
Okay, so currently we have 55 investors. We started with investor from Israeli investor, and all of them probably they are quite modest people, although they are holding each one of those family more than $100 million US dollar and beyond. But not many people heard about them. And in the last year, we have many investors from Latin America and from USA and some European. So in the last, I would say, 3 years, we just went global.
And maybe I will mention, I hope you don't mind me mentioning that, but I think this is something that people may wonder. When I was looking at the company and tried to find more information, I couldn't find a lot, and no really website, nothing like that. And I asked you about it, And I believe you explained to me that because we're dealing with such a sensitive topic as breast cancer and people's lives, you prefer to maintain a very low profile and not get, people calling you and asking, for you to already work with them and issues like that.
Yes, I mean, it's not so easy to get a telephone from a patient or from his relative that ask what else he can do in order that himself or his family friend will be part, and can we start it before we start. And it's not so easy call, I would say. So it's not an easy call, and therefore we decide to hold with our website. It probably we will put it on the air at the beginning of the next year, because once we start with human studies, so at that time we can discuss the company. And for the next couple of weeks, I prefer not to get so many calls from people that are really desperate, and I can understand it, but it's not easy task to make those calls. Yes.
Great, Ofer. Is there anything else you'd like to mention? I assume you're fine with us sending your contact info to those who registered today.
They have my contact?
Of course, we will be sending everybody by tomorrow at the same time. We will send the information to everybody else. Anything else, Ofer?
Yeah, I would be more than happy to get a call and to get a mail from people that want to discuss it seriously and be a part of our investor. Let's put the last screen, which I believe talk about it. Sorry. So that's it. I just hope that the audience will take a decision and join us.
That's great, and I definitely think that this is could be a breakthrough that is very, very interesting, which I think we see by the many questions we've received. I normally don't get so many questions so early on. So everybody, I would like to first of all thank Ofer. Remind you that next Tuesday we're still in the world of health. That obviously, by the way, Ofer becomes one of the hottest, or became already, even a hotter topic than before, given the fact the entire world is now, sees the importance in their face, let's say. So next week, we're talking to Mount Sinai, one of the most famous hospitals in New York and I think around the world, and we'll be talking about COVID and what's going on around there. And as I've mentioned, we have 2 conferences coming up October. So we're going to have the Canadian, the US conference, November 12th and 18th, and the Canadian October 28th and November 5th. Some of our speakers, just to show off a little bit: John Katsimatidis, Kara Kennedy, Como, both families that you know, Como and Kennedy, the Vice President of AI at NVIDIA, Levi Strauss, World Economic Forum, Microsoft, H&M, Boston Consulting Group, great next generation people that I see here. I will not go into details. Sandro Salzano, very famous from Latin America. Tim Gannon, a guy that developed a recipe for steaks that made him a multi-millionaire. Steve Apostolopoulos, we spoke about them. Philippe de Gaspé-Bombian, Francois de Gaspé-Bombian, Patricia Saputo, David Bento. These last 5 names are 5 of Canada's largest families. Other names like Uri Levin from Waze, from Israel, the founded Waze, Adam Saskin from Faskin, Elias from Saskin, Anthony Broccolini, a very known family as well in Canada. So join us there. And I'd like to thank everybody for joining us. Thank you, Ofer.
Thank you, Danny. Thank you very much.
We'll keep in touch, and thank you very much for joining us.
Thank you.
Thank you. Bye-bye.